Hello everyone, welcome to another Purdue competition video from the 2014 competition. One of the problems is a classic comp sci problem called the postfix problem. And in this one it introduces you the new notation. We're only going to have to worry about addition, subtraction, multiplication, division. We don't have to worry about parentheses or exponents, which makes our job shorter and a little bit easier. And so just to remind you of how postfix notation works, what you're used to in infix notation is you look for operators like multiplication, and because that is furthest to the left in the uh, expression, and it's the highest precedent operator in this expression, you evaluate the left token, the left number, and the right token multiplied together. Then you go to the next leftmost highest precedented operator, which would be division, and you do that operator. And then finally you do the last operator, subtraction. Um, for postfix, it works a little bit differently. The idea is that you use functionally a stack, which they don't tell you in the description of the problem. But you go through and you look at this expression, you see a 20, nothing to do there, a 4, nothing to do there, a 3, nothing to look there and do with it. But then when you see the multiply operator, that means you take the last two numbers you saw and you multiply them together and replace them with a 12. And that's what happens down here. So the 4 and 3 have been multiplied to be a 12, then you see a 2, nothing to do there. But now you see a divide by symbol, so then you divide 12 and 2 and get 6, and then you subtract 20 and 6. What's interesting to show is that postfix and infix notation, like you're used to, are actually always equivalent. You can write any expression in postfix and any one in infix. You do potentially need to add parentheses, but both formats are equivalent and are useful in different situations. So here's what you're going to have to do in this problem. You're going to have to be able to read in a number, so how many different things you're going to input, then take in a bunch of infix expressions or expressions that you're used to. There'll only be integer numbers, and the operators will only be minus, times, divide, and subtract, and add. And then the output is going to be, for each of these lines, the postfix expression and then the value of the expression. So let's look at my code. To save time, I've typed it all up and we're just going to look at it. So I have the input strings right here and I have the output strings for testing at the end. So to begin with, I have my main method, and what the main method does is it reads in the first number that the user types in, which indicates the number of test cases. I have a loop that runs that many times, and then I read in a test case. I then call a function that I'll show you below called toPostfix, and that's going to convert the line to postfix notation. Then I have another function I wrote called eval, which will take the postfix notation and evaluate it. Then I print it out. So we have to look at what my toPostfix function does and what my eval function does to understand how my program works. A couple of helper methods I wrote. I wanted to know if a individual letter, so the string needs to be length 1, if that's going to be an operator or not. So if it's an addition, subtraction, divide, or multiply, those will be my operators. And any numbers that this method sees will result in a false value. The precedence level function tells me the precedence level of an operator. So assuming that op here is either plus, minus, times, or divide, it's going to return 1 if it's an addition or subtraction because they're equal precedence. And if it's anything else, like multiply or divide, it's going to return 2. And so the higher value means that the operator needs to be evaluated earlier in the process. All right, so the first thing I want to look at is my toPostfix method, which is many, many lines of code, although the concepts are not crazy difficult. So what I do is, here is an infix string that I've split into its individual tokens or its individual components. And the idea is that you just go through and you find the highest order precedent that's furthest to the left. So in this case, that's multiply. And then you merge these three tokens, the thing to the left, the thing to the right, and the multiply, into one token where it's in postfix order. So that means the 4 comes first, then the 3, then the multiply. Then you do the same thing again. You look through and you find the next highest operator that's furthest to the left. Now times doesn't count anymore because this is not an operator, it's a blob of numbers and operators. So the only operator we have that is high order and furthest to the left is the divide. And so we do the same thing again. So we're going to combine 4 3 times with the 12 and the divide by symbol to create this kind of larger token. And then at the end we only have one more operator, the minus. So we take the 20, the 4 3 times 12 divide, and then combine it with a negative at the end. And so that's what my code is going to do here. So I first take my infix string and I split it around spaces to give me an array of all the different tokens. And then to make things easier on myself, I put it all into an array list. So here's my array list of strings. And then for each of the individual elements of the split infix string, I add it to the array list. Now, I do something that some CS teachers think are evil, but I thought it made my life easier. And I made a loop that said while true, so this is an infinite loop, and it's going to stop only when this break command happens. So here I'm looking for if in the tokens list, if there's a multiply symbol or if there's a divide by symbol. So this will give me a position in the array list. And if the values for both of them are -1, that means there are no more multiplies and divides, so I'm going to stop looking for them, which is why the loop would end. So let's say I actually did find some. Now this long block of code is making an important decision, which is what do I do if there is a multiply and a divide? What if there's only a multiply, or what if there's only a divide? So because what I want to do is I want to pick the operator that's furthest to the left. And if there is both a multiply and a divide, and this should really be greater than equal to 0. It's not wrong. You can't have an operator all the way to the left in infix or a postfix expression, but so it can't be at position 0. If that happened, that would be bad. So just in case it happens, I'll add that in here. This would probably cause our program to crash if that situation ever did occur, so we shouldn't have to worry about it. But I'm checking to see if I have both a multiply and a divide. If I do, I then decide which one comes first. So if the multiplication is at a bigger position than the division operator, that means that the division should come first because it's further to the left. And so I will pick that operator. Then otherwise, that means the multiplication needs to come first because it's further to the left. Notice I don't have to check for equality because you can't have both a multiply and divide in the same spot. So in that case, it doesn't matter. So what happens if you don't have both a multiply and a divide? Well, what if you just have a multiply? Well, then you should pick the multiply operator. That's clearly the furthest to the left. And otherwise, if it's not the multiply that's greater than equal to, the index of the multiply is not greater than equal to 0, then it must be the index of division that's greater than equal to 0. So I pick that one. So after this long block of code, I will know, I'll have picked an operator, either a multiply or divide, and it'll be the one that's furthest to the left in the string. Okay, so now I do the thing that I described above, which is that I get the token that's to the left of the operator, and I get the token that's to the right of the operator, and then I combine them together with spaces, and then the operator that I found afterwards. So at this point, though, the array list still has 3 separate slots for the token that's here, the token that's there, and as well as the old operator. So what I have to do is I have to remove 2 of those tokens because I'm merging them. So I don't want to have 3 spots, I want to just have 1. So I remove them. And then I'm going to set or replace one of them to be the merged token. Notice the order I'm doing this in too. I do want to go index +1, then index and index -1 to make my life easier, because when you remove from an array list, things will shift around at the end. So if you remove further to the right, the shifting will happen away from what you're actually doing. So yeah, remove this one, remove that one, replace, and then it'll go back around and do the loop again and try to see if there's any multiplies or divides. And so at some point, it'll find no more, and so in that case, the loop will end. Down here, I do the exact same thing for adds and subtracts, so I'm not going to spend a lot of time talking about it. I'll fix this case again, even though I don't think I should have to worry about it. So I'll look for adds and subtracts. If I don't find any, I'll end. I'll figure out if the add or subtracts that I do find, which one's the first one to the left. And then after I've found them, I do the taking out the tokens, merge them together, remove two of the tokens, and replace. By the end of all this, then our list should be down to one token. If it's not, there's a bug in the input string, not an input in our algorithm. And we're just going to return whatever our one token is in the list. All right, so that's the way that we could create a postfix expression. Now, how to evaluate it. As an example of using a stack, I'm going to show you the data structure and use. And you don't actually have to use a stack data structure for this. You can just use an array list and think of it as a stack. But so if our input string was this, already in postfix notation, the idea is you go one number at a time and you take from the input string and you put it into the stack. So when I get a 20, I take it from the input and I push it onto the stack. I see the 4, push it onto the stack. See the 3, push it onto the stack. And then when I see that I have a multiply, I pop the two things off the stack, the 4 and the 3, and multiply them together and push that number back onto the stack of 12. Now I see a 2, I push that onto the stack. I see a divide, I take the last two things off the stack, divide them, push that back onto the stack. And now I see a minus, so now I'm going to pop the last two things on the stack, subtract them, and push that on the stack. And then 14 would be the answer for the evaluation of this postfix expression. So the code for this is actually surprisingly short. The first thing I do is I make this stack object. So this is like an array list. The commands you can do on it are like push and pop. Push adds to the end of the stack. Pop removes from the end of the stack. So it's like an array list that has some of its features taken away. So now what I'm going to do, and this is sort of a fancy notation for this, I take the postfix string and I split it around spaces. So that's going to give me an array of each of the tokens in the postfix string, and then I'm looping through each of them. You could have stored the array in a variable and done other things, but this is shorter. So I'm going through each of the elements in the postfix string. First thing I check is if it's not an operator. So if S turns out to not be an operator, that means it's a number. So I'm going to go ahead and push that onto the stack. And I'm going to interpret it as an integer, so that way I can do operations with it later. So let's say I do run into an operator. So that's the case where I need to pop two things off the stack, and I'm going to have to come up with a result. Well, the way I come up with a result is dependent on whether or not S is add, subtract, multiply, or divide. And so I apply the operators, and they have to be in this order too. The second thing that you pop off the stack is the leftmost value that you're going to be using in your expression. And if you ever mess this up, you just test and go, oh, look, my answer's wrong, so I should switch them. So I do the operator, and then I push the value back on the stack. And then at the very end, after my loop is done, after I've gone through everything in the postfix string, whatever's left on the stack is what you pop off. And that's it. So I have shown you all the code. Now I probably should run it to make sure that it works and you believe me. So I'm going to copy the input string, so that way when I run it, I can paste it in, and it does show me the output that we want. We get 24, 3 times 2 divide minus, 14, 4, 5 plus, 9, 9, 10 times 2 minus, 88, and 3 divide 8, 5 times minus, and negative 37. Yay! So that's the postfix program. It's interesting if you want to look into other types of notations like prefix, where you put the operators first. There's a whole concept of trees that you can get into, as well as a way, expression trees, on how to evaluate these types of expressions, which you'll learn when you take a data structures class, probably in college. So hopefully this was helpful. Let me know if you have any questions.